I have yet another example of a trig identity problem. This time we're looking at cosine of theta over 1 minus sine of theta and cosine of theta over 1 plus sine of theta. Lot of algebra in these problems, all right? One of the important things that I need to remind you, algebra 1 is just unbelievably important, okay? This relies on you just having nailed, and again, you guys went through an honors algebra 1. Hopefully you knocked that course out of the park, because you've got to really be able to understand how to manipulate equations to go into an algebra 2 or a pre-cal or a calculus for that matter to be successful. So we're going to use those tools all over the place here as well. One of the really important ideas that hopefully you walked away from algebra 1 with, you need to be careful. If I have some kind of statement like, let's say I had something like x squared plus 5x over x squared plus 10x or something like that. Remember that you cannot take a denominator and break it up, okay? I can't say this is x squared over x squared plus 5x over 10x, okay? That doesn't work that way, okay? Because when you add fractions, you need common denominators, and you add with your common denominator staying the same, and your numerators get added. This is not how fractions work, okay? And so, you can kind of show that. If I have something like 4/8, for example, and I want to break this down as 1 plus 3 over, let's say something like 5 plus 3, okay? Does everybody agree that's 4, that's 8, these are the same thing, okay? If I write this as 1/5 plus 3 over 3, that's 1 and that's a fifth. 4/8 is not the same thing as 1 and a fifth, okay? This doesn't work, okay? But there are things that do work, okay? For example, if I wrote this as 1 plus 3 over 8, I could break up the numerator with a common denominator, okay? I could write this as 1 over 8 plus 3 over 8, and 1/8 plus 3/8 is the same thing as 4/8, okay? But notice, a sum or a difference, each term is still over that same denominator, okay? Meanwhile, I can't do it the other way around. If I had like 4 over 2 plus 6 or something like that, I cannot do 4 over 2 plus 4 over 6, okay? Splitting up the denominator with the same numerators, okay? That's 2, that's 2/3, this is not 2 2/3, okay? So my point is this, a sum or a difference in a numerator, you can break up the parts of the numerator in the sum or a difference as long as your denominator is the same, okay? You cannot break up a denominator with a sum or a difference, period, okay? Now, there will be some ways that we can get around this, but that's a really important understanding to have, okay? And it occasionally burns people in this unit. All right, so what do we have here? We have cosine over 1 minus sine, and we have cosine over 1 plus sine. The point I was making before, I cannot just do a cosine over 1 and then a cosine over sine, okay? I know a lot of you are looking there and saying, oh, look, it looks like a cotangent. But again, you've got a sum or a difference in the denominator. We can't break up a denominator that way, okay? So, same kind of thing is going to happen over here, all right? One of our strategies is going to be to write expressions in a different form, whatever we can do. And sometimes you write it in a different form and it doesn't help. And sometimes you write it in a different form and it does help, okay? So here's what I'm going to do. I have fractions with denominators that are different, but they're similar, okay? I'm going to try to add these two fractions with a common denominator, okay? Think about how you find a common denominator. If I had a fifth plus 2/3, okay? How would I find a common denominator? Well, you can always find a common denominator. It's not always the least common denominator, but it's a common denominator by multiplying your two denominators together, okay? 15. And then I can multiply top and bottom by 3 here, and I can multiply top and bottom by 5 here, and we'll get 3/15 plus 10/15, and we end up getting 13/15, okay? I'm going to do exactly the same thing here, okay? I'm going to find a common denominator by multiplying my two denominators together. In other words, I'm going to take this 1 minus sine of theta, and I'm going to multiply it by 1 plus sine of theta. And so my common denominator is going to be 1 minus sine of theta times 1 plus sine of theta, okay? But it's a fraction, so if this is going to be my common denominator, I also have to multiply the top by 1 plus sine of theta, okay? Over here, if my common denominator is going to be 1 minus sine of theta times 1 plus sine of theta, this denominator needs to be multiplied by 1 minus sine of theta. And if I multiply the bottom of the fraction by this, I also have to multiply the top of the fraction by 1 minus sine of theta. Okay? So notice our denominator now is the product of these two things. The numerator has to be multiplied by the same value. Okay? It is literally the same thing that you do when you add fractions with numbers. And I'm sure you probably had a rational functions unit at the end of Algebra 1. I know when I taught applied Algebra 1, okay, we didn't quite do this, but we did things with common denominators and variables. So I'm sure you've seen that at some point. You have to be careful with this, okay? I'm actually going to find my common denominator first, because notice I have a 1 plus sine of theta and a 1 minus sine of theta. That looks a lot like a difference of squares pattern, okay? And so when I multiply 1 plus sine of theta times 1 minus sine of theta, check out what's going to happen. 1 times 1 is 1. 1 times negative sine of theta is going to be negative sine of theta. 1 times sine of theta is going to be positive sine of theta. And then negative sine of theta times sine of theta is going to be negative sine squared. These two guys cancel. I just get 1 minus sine squared of theta. That's my common denominator, okay? And by the way, 1 minus sine squared of theta is actually the same thing as cosine squared of theta, which is a big part of the reason I multiplied by that in the first place. So anyway, long story short, my common denominators, when I multiply these, are going to end up being 1 minus sine squared of theta, okay? And my common denominator here is also going to be 1 minus sine squared of theta when I multiply these two things together. Let's get our numerators, okay? A little bit easier. 1 times cosine of theta is going to give me a cosine of theta. Sine of theta times a cosine of theta is going to give me sine of theta, cosine of theta. Okay? Over here, I have 1 times cosine of theta. I have negative sine of theta times cosine of theta. Okay? Be careful now, these two fractions are being subtracted. Okay? So, when you subtract fractions, if I have 5/8 and I subtract 1/8, I subtract 5 and 1, denominators stay the same. Okay? So our common denominator here is going to be 1 minus sine squared of theta. That's not changing. Okay? We're subtracting a cosine of theta, and we're subtracting a negative sine of theta, cosine of theta. So make sure that subtraction there ends up happening. And anyway, let's see what ends up happening here. So we're going to end up with cosine of theta minus cosine of theta. Those just go away. We've got a sine of theta, cosine of theta, minus negative sine of theta, cosine of theta. That's going to be the same thing. Minus and negative is the same thing as a plus. So I've got this plus the same thing. That's going to be 2 sines of theta, cosine of theta. Okay? And we got a 1 minus sine squared on the bottom. Remember I said most of these are going to simplify down to a single trig expression. So let's try to keep going here. 1 minus sine squared of theta is the same thing as cosine squared of theta, okay? And this is also really useful for another reason. Remember, we can't split a sum or a difference up in a denominator, okay? However, sometimes you can get rid of a sum or a difference in a denominator by using one of these statements. So instead of having 2 terms here, we can replace it and just have a cosine squared of theta. And now I just have 1 term in the denominator, okay? And again, as we know from Algebra 1, it's very easy to divide the same thing out of the numerator and denominator of a fraction. If you've got addition or subtraction, you've got a factor, things get a lot more complicated. But if I look at this, is there anything that divides out of the numerator and denominator? And the answer is yes. I can divide a cosine out of the top. I can divide one of the cosines out of the bottom. Okay, that's going to leave me with 2. By the way, 2 is 2 over 1, so I'm going to leave it outside. That's 2 sine of theta over cosine of theta. And if you notice, sine over cosine is equal to tangent. So this whole statement is just equal to 2 times the tangent of theta. And if you remember, that original expression we had was very complicated, simplifies down to something that's relatively simple. All right, so pretty challenging problem. Let's go on and take a look at one final identity, and we're going to look at another strategy that we have not seen yet. The new strategy that we have not seen yet is going to be used with this one. I'm going to have -5 secant cubed. I'm going to use an x variable this time. It doesn't matter. If you don't like the x, you can use a theta. Minus 5 sine of x cosine squared of x. Okay, kind of cram that in there, sorry. All right, so I want to try to simplify this thing down. Remember, one of your strategies is to write it in other forms. Remember earlier we had one with parentheses and we multiplied out parentheses. There are no parentheses to be multiplied out, but I do notice there's a -5 and there's a -5, and both of these have a sign. You can also go the other direction. You can put in parentheses by factoring out a greatest common factor. You can divide out a GCF of -5 and of sine of x. So I'm going to divide out a -5 sine of x, and I'm going to see what I have left. Okay? So if I divide this by -5, we just have a 1. If I divide this by a sine of x, I'm left with 2 sines. I'm left with the sine squared of x. Okay? If I divide -5 out of this, I'm left with a positive 1. -5 divided by -5 is positive 1. If I divide a sine of x out here, I'm just left with a cosine squared of x. And I love this situation. Check it out. We've got a sine squared of x plus a cosine squared of x, which is always going to be equal to 1. Okay? So we have a 1 here being multiplied by -5 sine of x. Okay? 1 times anything, right? Because this is just equal to 1, is just equal to the value. This whole thing just simplifies down to -5 sine of x. Okay, so be on the lookout. If you can get a sine squared plus a cosine squared by factoring, or if you can multiply things out and get a sine squared plus a cosine squared, you get a really nice simplification, all right? So again, lots of different strategies here, and you really have to do a lot of trial and error and ask questions, and I really encourage you, if you can find some members of the class to meet on Google Meet or Skype or something like that, really encourage you to do this, because a lot of you are going to do the same problem 2 different ways, and one way will be 3 steps and somebody else's will be 12 steps, or they'll make a mistake in step 9 or something like that. So trying to come up with efficient methods is also really important. So lots of different strategies here. Basic strategies like if you see secants or cosecants or cotangents, maybe replacing them with their reciprocals, trying to write everything using sines, cosines, and tangents. But sometimes going even beyond that, trying to write everything just using sines and cosines, taking all your tangents and cotangents and writing them as sine over cosine or cosine over sine. Sometimes you can get it down to just sines and cosines, and that makes it easy to simplify. If you've got parentheses, sometimes multiplying your parentheses out can be helpful. If you see a sine squared or a cosine squared, trying to link it to this statement is useful. If you see a tangent squared or a secant squared, or a cotangent squared or a cosecant squared, try to link it to one of those statements can be helpful. Remember that you can rewrite these statements. So sine squared, if you subtract cosine squared from both sides, is equal to 1 minus cosine squared. If you subtract sine squared from both sides of this statement, cosine squared is 1 minus sine squared. By the way, you can do that with these other statements. You can subtract 1 from both sides. Your tangent squared would be the same thing as secant squared minus 1. Okay? Cotangent squared is going to be the same thing as cosecant squared minus 1. Or you can subtract tangent squared from both sides. 1 would be equal to secant squared minus tangent squared. 1 would be equal to cosecant squared minus cotangent squared. So if you see any of those square terms, look and see if you can link to one of those. If you've got parentheses, multiply out your parentheses. If you don't have parentheses and you notice a greatest common factor, factor out your greatest common factor. See if you can generate something that simplifies down to something easier. Okay? If you've got fractions with different denominators, try getting a common denominator. If you've got a sum or a difference in a denominator with one of these guys, replace it with one of these, and you'll have something that's a little bit easier to simplify. Another strategy that we haven't seen here, but I've kind of implied, let's say you have something like sine squared of theta plus, let's do I don't know, tangent of theta or something like that, over a sine squared of theta. Remember, if you have a sum or a difference in a numerator, you can break that fraction up using a common denominator, and just your numerator breaks into 2 parts. So you could write this as sine squared of theta over sine squared of theta, okay, plus tangent of theta over sine squared of theta. And so, for example, here, this is going to equal 1. So notice we've got a common denominator here. You would add your 2 numerators, and so this will be the equivalent. that just simplifies down to 1. And I don't know that this is necessarily going to simplify very much. Tangent's the same thing as a sine over a cosine. Oh, actually, it will simplify. Tangent is the same thing, so you might bring your tangent out here like this. Tangent's the same thing as sine over cosine. So you could do a sine over cosine in place of your tangent, and this is all being multiplied, so you can divide a sine out of the top and the bottom, and you get 1 plus, still not super simple, but you get 1 over sine of theta, cosine of theta, okay? I doubt that's going to simplify a whole lot more, but that's the basic idea. Or actually, you could flip these two up to the top, and you could write it as a cosecant of theta times a secant of theta. You could do the reciprocal there. Something like that. So anyway, that's certainly a lot more simple than the original. So anyway, lots of different strategies to think about. Again, you'll kind of feel these out and hopefully work with some other people as well. But hopefully these examples have at least given you some ideas about things that you have in your toolbox to try. And we'll continue to build on this over the next few days.